Good morning. Okay, another short video. The last video I made for my friend in Canada showing a small dovetail cutter that I used to get in some tight spots. So anyway, but the reason that I was cutting the dovetails, and I didn't mention it in the video, that I've been working on some type of a offset unit for the tailstock of the lathe. The idea is to be able to offset the tailstock to cut tapers, such as a Morse Taper. So I've been working on that. I looked on YouTube. I found a couple of videos. I won't say who published them, but I've tried a couple different methods, and I think I've come up with one that's simple and works pretty well. So I'm going to make a short video. I don't know if I'll do any machining in the video, but I'm going to get ready to I don't know what I did with it now, but I'm going to get ready to cut a Morse Taper on a piece of mild steel. So I may show some of that. I may show some of the setup. I don't know, but we'll see how much time we have. But I want to keep it, try to keep it short. Some of these videos have been getting kind of long. Here's the unit that I built. Okay, and let me hang on just a second. Let me grab a piece of steel. I had a bunch of drops that were given to me by my neighbor, and they're 4130. They're 4130 drops, and they're a couple inches long, and they're about 2 1/4 inches in diameter. I don't remember exactly what they were, but they're pretty good size. Yeah, they're about 2 1/4 inches in diameter. I've cleaned them up. They were pretty gross looking, so I had 4 or 5 of them, so I put them on the lathe and cleaned them up. But so anyway, I thought, well, you know, I had that. I thought maybe I can use that in order to make a unit, offset type unit. So here's what I came up with. Very simple. It's a couple inches long. Let's see what it is here. Yeah, it's about 2 1/4 inches long, and about 2 1/4 inches in diameter, right? It just started out as this piece of raw material, and so what I did was I turned down one half of it, and this is the half that goes onto the tailstock, and in this case I turned it down to about 1.5 inches, and I wanted a lot of meat here because I knew I was going to put a set screw in this, and I'll tell you why I did it this way. And because I had problems on a previous one that I tried to build from what somebody else had already done or similar. So anyway, that's what I did, and this end I just cleaned up the diameter. I put it in the mill and milled a flat on each side of it. Okay, that way it made it easier to do the dovetails. So all I did, this bore in here for the quill, I made a really tight push fit, so that there's no wiggle wobble or nothing in that. That's a nice tight fit. And I tried to do the same with the dovetails. I tried to make them a nice tight fit, no jib, no nothing, and they came out pretty good. They're not as tight as I like, but you know they have to move, so they're a little touchy they're a little fiddly, to say the least. And then what I did, I put a couple of nylon tipped set screws up here that I can tighten against the quill. I put a set screw here and a flat on the point that I made. This is just a piece of 9/16 01 steel, so it's hardened. At least the tip is hard. So, and then I put 2 nylon tipped set screws up here, and I don't think it takes a lot to hold a dovetail. I think it you know, it's pretty easy to hold. So if you tighten these 2 down good, that I don't think that's going anywhere. So that's the unit that I made. I'm gonna throw in one more thing here. Let me grab it. Here's a unit that I made, and it's got a lot of mistakes, so don't don't look at those. What happens with this unit is that basically it's made the same way. It's bored for the quill, and you'll see a sleeve in there, a steel sleeve, because I made a mistake the first time. I got a little bit loose, and so I wasn't happy with it, so I bored it out a little bit more and put a sleeve in there and then rebored it. So that's why that is. But this is a nice tight fit onto the quill also. The one I saw on YouTube was sort of made like this, and they put a set screw in the bottom, and that's what this one. You'll see an extra screw slot down there too. There's an extra threaded hole, because that's another mistake. But the thing is on the bottom of the quill, there's always I think there's always a keyway down there. It doesn't come through to the front of the quill, but it's there. So the person on YouTube, their attempt, and they say they were successful. I don't know. I wasn't. But if you push this onto the quill and tighten up a set screw, a dog point, or whatever it is down here, and try to align that with the keyway in the bottom of the quill, it becomes pretty difficult. And when you tighten it up, you're gonna move this one way or the other. You got to be extremely lucky to hit that dead on. But that wasn't the big problem. The big problem was that on a mini lathe, which is what I have here, the bottom of the keyway, so to speak, is paper thin. I mean literally paper thin. So if you put a dog point set screw in there and put any tighten it at all, you'll punch a hole right through the quill. And so now you've punched a hole through the quill, and your Morse taper in the internal part of the quill is also messed up. So that is not a good idea. So what I did to compensate for that, and I didn't have a slitting saw big enough, but I made a slit through here. In my case, I just used an 1/8" end mill, but I made a slit through here and a slit through here, and I put a 1032 screw in here, and I can tighten that up. So now I can slide this onto the quill, and I can tighten the screw up, and this works perfect. So I didn't need any of this crap on the bottom. Wasn't necessary, and to me, for my situation, it wasn't a good idea. For somebody else, it might be wonderful, but for me, it wasn't a good idea. Now, on the other end of this unit, I cut a thread on there. I think it's 7/8 20, but this is the thread that fits a import type boring head. So actually, that worked. I actually made a Morse taper with this, and it did work. I will say that. So this might be a possibility, but I realized that the hole, or the bore in the female bore in the boring head is not really perfectly concentric. It's close. It's close. It turns out that if I mount this with the clamping screw in the up position, so to speak, the centers won't line up. You know, if I turn it 180 degrees around, they will. And it's not off by much, but it's off by enough. So that's not a good idea either in reality. So I decided I need to figure out some other way to accomplish this. So anyway, so I came up with the other unit that I came up with, and I've tried this. It works quite nicely. So there's no problems at all. So that said, I'm going to shut the camera off now, and I'll bring you back. But I'm going to mount this on the lathe right now and tighten the set screws. And also, what I'm going to do then is I'm going to run a dial indicator across the dovetails and get this horizontally aligned perfectly. Is what I'm going to do. And I did discover one other thing. On these, the quill, when it's not locked, is actually will move a few thousand side to side. It's just a little wiggle. But the thing is, when you put this on, you need to make sure it's locked to one side, and then get it dialed in, right? But that's a simple process to dial it in. Just put a dial indicator across the dovetails and run it across there, and you can get that dialed in perfectly in a few minutes. Now, some people have worried about, I can see they think that you need some kind of a fine adjustment for this right here. And you have that with the boring head, right? So that actually facilitates a fine adjustment. But that, if you got a nice snug dovetail here, you know, you can put your dial indicator on, and you can get your taper dialed in really easily, just tapping this one way or the other, whichever way you're going to go. So anyway, that's I was going to do something for a fine adjustment, but it's not necessary, at least in my case. This dovetail is nice and snug, and actually what I can do is these nylon tip set screws, I can just put a little pressure on those, and I can still move the dovetail, and that gives you a little more resistance and a little easier to dial it in. But you can dial it in so easy, it just takes a few minutes. In this case too, what you need to dial it in is you need a DRO on the lathe, really, on the what do you call it? I guess I'd call it the x-axis or the axis along the waist. But I just use 2 inches. I have a 2-inch dial indicator that I use, and that's good enough. You know, like if you're setting up a Morse Taper, you've got 25 thousandths per inch. So if you just use 2 inches, that's 50 thousandths, and that works. I'd like to make it like, you know, 3 inches, right, or something, but I can't with the dial indicator I have. And there's no good way to put a DRO. I have some old linear DRO type things that I used at one time, but there's no good way to mount it on the mini lathe. Otherwise, you're going to have a lot of debris in it and everything else. So the dial indicator, the 2-inch dial indicator, seems to work pretty good. Okay, that's a quick overview of this unit. And let me, if you slide it apart, just simple dovetail is all it is. You know, you can see the 2 nylon tip set screws coming through, and you can see the point, the base of the point. And also, in using this, I realized that that if you tighten the quill down too tight, and put pressure on this center here. Then you, no matter how nice snug fit you have on the center, it'll start rotating on you. So you need a flat on the top of the center. So that's what this set screw goes to, the flat. Anyway, so let me shut the camera off now, and let me get this thing set up. Okay, I pushed the unit onto the quill, and I set up a dial indicator across the dovetail. I'm sorry you can't see very well, but I have no place to set the camera up, so I'm kind of sorry out of luck. Anyway, I've got this thing zeroed. I'm only using half the dovetail to scan back and forth, but anyway, it's right on zero. So now I'm going to, and I've got this locked down, and the play's been taken out of it initially. So now what I'm going to do is lock these two set screws up here. And look at that. They're staying right on zero. So I want to make sure these are good and tight. They're nylon, so there's a little bit of resilience in them. Okay, there we go. Well, that's the end of that process. I'll set this out of the way temporarily. I can put the dovetails back together here. So there we go. So now I'm going to have to put the piece in here that I'm going to put the Morse taper on. So one thing that I realized also is that I got to be able to get in here to do this, and that means I need enough room. Where's my brush? Got a bunch of garbage down in here. I need enough room to do it, and right now I don't have that room. What I need to do is bring this back to at least there. So there we go. And you can't see that, I guess. I wish I could set this camera up someplace else. But anyway, so now what I'm going to have to do is I'm going to have to get some dial indicators set up here, and I think we need a dial indicator going along the work so we can adjust the angle, and we need the 2-inch dial indicator set up here somewhere here so we can check the travel at the same time. And we need to go back and forth until we get it right. So I'm just going to try to get this set up somehow. Take some of the slack out of it. Let me get all the little notches oriented right here, so I can do this. Not the best situation in the world, that's for sure. I think we can probably get it set up here someplace. Well, there we go. Let me shut the camera off till I get this set up. I see it's kind of fiddly. Okay, it took me a few minutes. Hopefully it works. A little bit fiddly to get it set up. So I've got one dial indicator. Let me zoom out just a little bit. I can see that that's not working very well. So I got one dial indicator here measuring the carriage travel, and I got another dial indicator here measuring the how much the offset is, right? And I have a carriage stop set up. So right there it's 0. What I want to do is travel 2 inches, and in 2 inches at 25 thousandths per inch, that's 50 thousandths, right? So let's see if I can travel 2 inches here. And I should put a mark on this thing just as an indicator. So it looks like that's 2 inches right there. I'm gonna put a little dot on the top of this workpiece here, just to let me know that that's the 2 inch mark, so I don't get confused reading the dial indicator. And then so at that point I need to be offset 50 thousandths. So I'm going to move this over 50 thousandths. So there it is, 50 thousandths. So I'm going to go back again to where I have the stop set up, which is 0, and it's moved, right? Because keep moving both places at the same time. So I've got to go back to 0 again and go back 2 inches this way, which is right there, and I've got to get this thing set at 50 thousandths. Okay, a little bit fiddly, but I go back to 0 again. So it's back and forth till we get this lined up. At this point, what I'll do is eventually I'll tighten those grub screws up a little bit and keep working this till I get it. So it's going to be a back and forth ordeal. Oh, shut the camera. Okay, it took about probably 10 times. I didn't keep track, but it took a few times back and forth, but it's right on the money now. Exactly right. It's both indicators are right on 0. So we're in good shape. So we should be able to cut the taper. Get this off here. We don't need that. And we don't need this anymore. We can get rid of it. Okay, so there we go. Now the question is, we can go ahead and take things in and out of here with no problem. So I think at this point probably need to put a little grease on here for one thing. So there's that. There's that. So there's a little grease on there. Now I got to remember, when I loosen and tighten this thing, I got to make sure that the play's out of it in the direction that I've chosen. So I think this carriage stop is going to be good. It's going to be out of my way, I hope. Yeah, looks good. Let's tighten this up a little bit. Unfortunately, we don't have a ball bearing center in there. That'd be nice, but not something we have. So that's just a piece of that center, just a piece of old one that I hardened up. Now I'm not sure. We've got a couple different tool holders here. Let's see which one. So we're going to have to back this off. Well, it looks like I can get that in there, no problem. So I've got, this is a piece of scrap, so I've got a little offset in there that should come out eventually. So I'll touch off and see if I can get by this shoulder here. I'm just going to take it slow by hand and just take it off there without using the power feed. There we go. Let's just set the power. Let's just take off about. Let's see if this cutter does it. Put a little oil on the work. It's running nice and smooth. I don't see any problems. So we're good. Turn up the speed a little bit. There's that shoulder. I don't know what we're taking off there, but right now I'm going to keep it. I'm not going to take any chances. Don't want to. We're going to get by that shoulder in a few minutes. Now we know that this is a number 2 Morse taper, right? So all these Morse tapers have about the same bevel. They're all about 25 thousandths per inch. They're actually 50 thousandths per inch, but you know, we're using a lathe, right? So to take off 50 thousandths, we dial in 25. So that's smooth as glass. There's the shoulder again. This time it's going to take it out, so we don't have a shoulder anymore. So we're going to keep doing this until this taper should be about 2.5 inches long. But by the way, the diameter of this piece of material is about the size of the large end of the Morse taper. It just happened to work out that way. It was a piece of scrap, so let's see here. I have the chart here, the Morse taper chart. So all we're interested in is the number 2. So the large end is 0.7, the small end is 0.572. So we're going to keep going here until we get the small end down to 0.572. And then we'll give it a try. I've got a sleeve here, which is actually, this enables me to reduce the spindle from a number 3 down to a number 2. So we can use this as a test with once we get this thing down to size and just see how good the fit is. So this is going to take a few minutes. I'm going to take off a little bit more here. Maybe speed up the process. Maybe. that might be a little much. Okay, I'm going to shut the camera and I'll bring you back. Okay, I'm going to check and see where I'm at here. I'm going to try to check right at the small end. Let's see what that thing was supposed to be. Small end was supposed to be 5.572. So let's see if I can figure this out. We're at 6.6. So we're at 0.6 minus 0.572 equals, divided by 2 equals 14 thousandths. So we only have 14 thousandths to go. I'm gonna make this pass, and then I'm gonna give it a little polish, and we'll see where we're at. Okay, doesn't look beautiful, but I hit it with some emery, and so I could do something. I could make a better cut, that's for sure. But it's all right. I haven't tried it yet, so let's give it a try. What did I do with the sleeve now? I had the thing here, and I misplaced it. Well, where did I put the darn thing? Oh, shut the camera off again. Let's see if I can find it. What did I do with the sleeve? Okay, it was laying right in front of me. Like a dummy. Maybe I gotta zoom out a little bit more, huh? So there it is. Boy, beautiful. Beautiful fit. I got just enough room to be able to, I got a little tang on the end there to be able to reject it or eject it out of there. Oh, that's pretty nice, actually. I know it's not perfect. We'll have to work on that, but at least it doesn't wobble. And I'm going to put some marker on here just to scribble it on here. Let's see. I got a feeling that it doesn't wobble, but also it's, and the inside of the sleeve is pretty smooth, so I'm not sure how much of a print we can get with this. Just a, what do you call it? One of those markers. Sharpie, I guess is the right word. Oh, beautiful. Beautiful. I got nice coverage. A couple places they're a lot heavier than others, but I got, yeah, right here at the end. It's still kind of black, but let's see if, boy, if I can get it apart now. Oh, nope, I can't get it apart. Well, I'll have to find my little wedge and knock it apart. Anyway, I guess that I can call that successful. So I'll take this out. This is a nice, well, get this out of here. This is a nice push fit on there. So there it is. You can see how much offset. Now that offset depends. What you really need to do is to make sure when you initially set this up. I can get this out of here. Boy, it's really tight. Anyway, it's important that you set up your dial indicators with the original workpiece, the workpiece you're going to use to cut the taper, because the length of that workpiece is important. So if you need the right one, the one you're going to cut the taper on, then you're good to go. And that came out absolutely perfect. So anyway, so I'm going to post this video. I guess it's going to work out okay. Okay, I'll call off now. I hope you got something out of that. And talk to you later. Bye-bye.